Hi, everyone. So I hope the first lesson went well. I wanted to take this opportunity to now say great job at staying on track with it. I know it's hard with this distance learning, but we had a really good start. And so here is the start of the second lesson. Your due now is to complete an entrance ticket. So normally this entrance ticket would be given to you in class and you would have 20 minutes to take it. So I want you to do this as if you were in class. Therefore, try to do it without using your notes. And when you're done, you're going to upload a copy of your work to Google Classroom. The assignment is called Lesson 10 Entrance Ticket. And on that Google, I've actually posted the assignment as well. And so if you'd like to download it and you have a printer you'd like to print it out, feel free and print it out as well. I'm going to remind you that after this pause, you'll have the interactive where you're going to input your answers for some of the questions. I'm going to remind you that you should be writing your intercepts with no spaces and your slopes using this type of form. So if it's an integer, you don't have to say divided by 1. If it's a fraction, write it as such. For those of you who don't want to go open it up on Google Classroom right now, here are the 3 questions that you are going to be completing for your exit ticket. So at this point, I'm going to pause it, and you're going to take 20 minutes to try to do this assignment. So now that you've hopefully uploaded the entrance ticket, here are the answers. Now, I want you to check yourself, so that's okay. Now, when we run out of money, well, y represents our money. So therefore, y equals 0, no money. And when y is 0, we're finding the x-intercept. And when you plug in 0 for y, you get 20 for x. So our intercept is 20, 0. Our original amount means we haven't had any days pass. That means x equals 0. So that's our y-intercept. And when you plug that in, you get 0, 500. You'll see that I've solved the slope in 2. Make sure you fully simplified it. And for question number 3, I used the slope formula. I plugged it in and I got 8 minus a negative 1 all over r minus 7. Now, I chose to do 8 minus negative 1 versus negative 1 minus 8, so I would deal with r minus 7. I'd rather deal with r having a coefficient of 1. That's simplified to the 9 over r minus 7, and that therefore equals our slope negative 3 over 4. I use cross multiplication, which therefore resulted in a negative 3 multiplied by r minus 7 equals 36. I divided both sides by negative 3 to get here, and I added 7 to get to r. And you can actually then go and plug that in and check. If you have any questions on this, make sure you come into the Google meeting to meet with me. So let's go on with today's lessons. So here's what we're going to be doing post-entrance ticket. Now, make sure you take notes on the following parts of the video, because at the end, I'm asking you to upload this as well into Lesson 10's notes upload. So below are 2 of the 3 special forms. Now, we've learned one, slope-intercept, and now we're learning point-slope. Now, point-slope, you should see, also has an m in it. That m is the exact same slope we've been dealing with. As you see, x1 comma y1, we used that notation when we were dealing with slope. And when we put that little 1, that means it's an actual point. So this represents a placeholder, not a variable. That's where we're going to put the actual point. Versus x and y, which again represents the variable. So if needed, pause the video at this point to add that to your notes. So hopefully you now have that in your notes, and we're going to start to put that to use. Now, I'm going to have us state the y-intercept or given point, state the slope, and then graph the equation using the information for two examples. So let's take a look at the examples. Now, the one on the left is very similar to slope-intercept form. It's exactly slope-intercept form. It's y equals a coefficient multiplied by x with a constant at the end. So therefore, if I'm looking for the slope, the y-intercept or a key point, in this case, it's the y-intercept. The b is here. Now notice that I highlighted that 6 as well. So our y-intercept is 0, -6. That's our key point. Our slope, if we take a look at our slope, well, the slope is the coefficient of x, and there is my coefficient of x. So therefore, my slope is 1/3. I can now use this information. I'm going to start with my y-intercept. Well, my y-intercept is down here at 0, -6. My slope says go up 1 and then run 3. That's my next point. I now have enough information to graph my line. Now, point slope's going to be a little challenging, so stick with me for a moment. And if you need to pause the video at any point, feel free and pause it. Now, I'm going to start with the slope because I already have the highlighter green. So there's the slope because the slope is the coefficient of the bracket. So therefore, m equals 3. That's the same as 3/1 because we're going to be using that when we're graphing. Now, the issue that we then see and come across is we have that it's a minus y1, a minus x1. Well, here we have a +3 and a -4. So we have to ask ourselves, what was substituted in to x1? So we're thinking here it's minus a 4. So that means x1 is 4. But when we see a plus a 3, that's the same thing as saying minus a -3. So that means our y1 is -3. So our ordered pair is therefore 4, comma, -3. Again, let me show you that again, and I'm going to do a different example. I'm going to start with the fact that I have the basic case. And I'm going to say, plug in the point, -2, 3. Let's see what happens. So again, the -2 is going to replace the x1. The 3 is going to replace the y1. So we have a y minus, well, that's a 3, equals our m. I haven't given that to you, but you would have it. X minus x1, which is a -2. Well, minus a -2 becomes plus a 2. So when we see a plus sign, like over here on +3, that means we substituted in a negative. Okay, let's now graph. Our point is 4, -3. So I'm going to plot that. Our slope is going up 1, 2, 3 over 1. There's my second point. And there is my graph. Now, both of these examples should be in your notes. So if needed, pause the video. And after this, you're going to have some practice. So here is your practice now. There's 4 questions. You are going to write down all the practice problems in your notebook. State the key information. So can you pull out the y-intercept or the slope? Determine from the practice problems. Use the practice problems to help. Input this key information into Play Pause It. So the questions are going to show up next. Make sure you read the instructions carefully. And then graph the function in your notebook. Best of luck. And if you get stuck, again, come meet me in Google Meet. If it's not class time, send me a detailed email saying which question you're struggling on. Okay. Now, after we did that practice problem, we're going to think for a moment about what's going on here. I want you to look at these 4 challenge questions and think about what makes them difficult to pull out the key information, unlike the 4 practice problems you just did. So take a moment, stop, and think. So I hope you noticed that none of these are in the exact form we want. So let's look at slope-intercept form, y equals mx plus b. Well, question 1 and 3 look like it, but they're not in the form y equals. Question 1 is negative 2y equals, and question 3 is 5y equals. So I suggest you adding these to your notes as well. But all we have to do is put them in that form. And so I'm going to use our inverse operations. I need to get rid of multiplying by negative 2. So I'm going to divide both sides by negative 2. That results in the side y for the left side. And the right side, don't forget to divide both. So I have a negative 2x divided by negative 2, which is just a 1x, and a positive 16 divided by negative 2, which is a negative 8. Now I'm in slope-intercept form. So I can do a similar thing for question 3 and divide both sides by 5. And I get y equals 4x minus 3. And again, I am now in slope-intercept form. Now for 2 and 4 is point-slope form. So let's write it down, because the more we see it, the more we write it, the better. Now the only challenging thing about question 4 is the way slope is written, because we deal with rise over run, so decimal is difficult. So I'm going to rewrite 2.5 as 5/2. Now we can see that the slope is rising 5 and running 2. So it's just that little change, but it makes it so much clearer. Well, question 2, the issue is this plus 4 is over here. We need to bring that to the other side for the y minus y1. Well, as we saw with example 1 and 3, I could just do inverse operations. Well, now my left side is y minus 4, and my right side is negative 1, 7, multiplied by x plus 9. Again, just because point slope is new and a little more challenging, the point in question 2 is going to be a negative 9, comma 4. And the point in question 4 is a negative 1, comma negative 3. Again, if you have any questions, just come into Google Meet. This last part of today's lesson is going to be an independent exploration. Now, usually this is where you would be working with 1 or 2 other people. So in class right now, you can see if someone on our assignment sheet is working on this. So feel free to message someone from our class as you are discussing this. I highly suggest it. Your goal is to write an equation in slope-intercept form for the odd ones. So I should see an equation in this form for both 1 and 3. And then you are going to write an equation in point slope form for both 2 and 4. So best of luck. Let's see what you come up with. So how'd that go? So slope-intercept form, there is only one option because there's only one y-intercept. So as you see here, what I did was I found the y-intercept, which was negative 5. And then I just counted to another point. So I found the other point, which was right here. Now you have to make sure it goes exactly through it. And I counted and I got the slope of 7. I did the same for 3. I found the y-intercept, happened to be the same value. I found another point, which happened to be right there. And I again counted the slope. In this case, it was down 6 over 1, so slope of -6. Now for 2 and 4, what will always be the same is the slope, but the point you use will give you the same equation. It will just look different, but there's infinite points. So notice that I dotted some of the points in black on question 2 and 4. Now I counted the slope just from the graph. And notice again, so it's 2, because it's always 2 for this function. And for this one, it's always -7/4. And you'll see, here is the point that I use, 2 comma 1. That's why it's x minus 2, a y minus 1. Here I use the point 1 comma -1. You might have used a different point, but it's still the same function. There's a few questions at the end of this assignment that you're going to be doing, and that's going to be your homework. So complete those questions, and then I will see you next class. One last reminder, don't forget to do those questions in your notes because that will be a part of what you upload to Google Classroom. Bye.